let me start again. Okay, so we are trying to solve this scenario, and what I told you is to read while you read the whole thing. In this thing, you have to pay attention to the details. Okay, and read slowly. Don't skip a word, but don't over do the word that you possibly can. Right? There's nothing hidden in such scenarios. Okay. Consider a manufacturing sealer plant that receives two kinds of entities. Entity A with arrival following a distribution exponential 5 minutes, and entity B with 4 arrivals together. Use like your pencil or pen to underline those key information. With exponential distribution 30. So I've asked you to find what arena component you need, and you said that you'll be needing create, right? And because there are 2 types, so you need 2 creates. So that's like the first lesson you learned. Each type required its own create. Okay. So if you have 3 types, it means 3 creates. 4 types means 4 creates. So each type will have its own creation. Okay. Now, if that is done, so what have you written in the box? So you click on the create, and so what are the options available? Okay, name. Have you can rename like entity A and entity B, or what's the other one? What is type? Can you drop the IC? Okay, just leave that. I think it's beyond just. Is there something on arrival distribution? Yep. Does it say expo something? So when you see random expo, it means it's an exponential distribution, and exponential distribution just needs one parameter. So what is for the first one? What is the value of that parameter? What do you call that parameter in exponential? Yeah, we were talking about it yesterday. I mean, day before yesterday. Lambda, right? So the lambda, what's the value of in fact, to be more precise, 1 over lambda? It's 5 minutes. Okay. So what do you have to write after expo, random expo? So you will be writing 5 plus. It's not enough. It's just something written right after that on the right side. What is that unit written there? You need to keep it minutes. If it is an hour, you're saying that on average every 5 minutes, a part is arriving. But here you're saying every 5 minutes. So you can see that it will be a huge difference. Okay. So once you have done that, so do that for the second one. But there's an option for the second one, 4 arrivals together. See if you can handle that in that box for the second one. So what do you write there? 4. You'll write 4 there. Okay. Are you all done with this step? Now, what does it say next? For entity A, the process firstly involves a preparation step, specialized location for entity A only following. What do you call this distribution? TRIA 148 means, what is that? It's, what do you call this distribution? It's called triangular. We discussed that. Triangular has a shape like a triangle. And I told you, when you don't know anything, you just know the range, you use uniform. But you know the range plus the most likely value, then you are following what is called. So that peak is like the most likely value. And you know the minimum and the maximum possible. Okay. So this is what it is capturing. And again, the unit is, so what are you looking at? Create, dispose, decide, process. Yeah, seems like a process because now it's like a service, isn't it? So you have a specialized service for A only. So drop a process. Is it connected to anything? This process. It's already, it has made the connection. If not, there's an icon on top which shows connection. So if there's no connection, you can click on it. You can delete a connection. You can make a connection by yourself. Okay. So don't worry if it is not making any connection. You can even click on a line and delete. Okay. I'm going to show you once I go there. I want you to right now not look at the solution. Okay. That's why we are going. We are moving ahead. Okay. Now process. So what's the distribution here? Triangular 1, 4, 8. 1 is the minimum, 8 is the maximum, and 4 is the most likely value. Okay, and the time is minutes. But once you drawn the process now on the screen. So you have clicked on it. What is the first thing you see on top? The name. Give it a name. Preparation A, entity A prep or A prep. Something whatever you like. A prep or prep A. Say that again. Is 4. Look, there has to be two extremes. One is the minimum, the maximum. So things fall between that, right? So the one that is not the two extreme is the most likely value. Okay. What's the name? Name of the process. Okay. So you can give it a name, prep A or something. Okay. There's something called standard priority. Just ignore that. You know, it has an implication, but at a more advanced level. But then there is something else you must be looking at after name. Action. So do you remember our discussion yesterday on action? Cease, delay, release. When do you use cease, delay, release? When do you use cease, delay, release? I can't hear you well. I think someone is saying from this side. Not the list. Can you be more precise? When you're making use of a resource to get service. It means what? I need a nurse to attend to me, right? So nurse is a resource. So I go to a nurse. Seizing means like now the nurse is, I have seized the resource means now the nurse will be serving me. And then delay means it is the period where I'm getting my service, and then I have to release it because from Python experience you have to be explicit, right? You have to tell that in normal circumstances you say okay, thank you, and you leave. But you're using a queue or something, but everybody understands that you have released the nurse, so the nurse can attend to another patient, right? Or on a cash counter you say thank you, and another one just can understand that you have released the resource. But here you say cease, delay, release. When you say cease, delay, it means that you're not releasing the resource. You want to carry resource to the next step, and you want to release. You know, it usually comes with a combination of delay, release. Cease, delay, and then there's a delay, release. Right? So that's what we are not doing right now. But if in your case, step 1, you capture a resource, you take that resource with you to the next step, and then you release. So that's when you use it, just for the sake of knowledge. Okay. So in this case, you're just preparing and then let it go to the next stage. So we are looking at cease, delay, release, right? When you say cease, delay, release, it means what? We are making use of have we created a resource yet? So there's an option to add a resource, right? You see an add resource in front of a list. There's an empty list. So you need to add a resource. So you need to give a name, you know, a preparation machine, or preparation station, preparation person. It could be a combination of a machine and a person. Departure from that step, not from the process. Understand that? So when I say release, I'm going to the next station, and I say resource is available for the next person. I'm moving on to the next stage. which could be another step. Okay. Okay. So now what? Have you created a resource now? Is there number of units? If you need there 2 people working, then you add 2. If you need 1, you add 1. There's no information given, so you assume, the whole process as 1. It could be a combination of a machine and a person. Okay. But if you want to be precise, if you need like total 3 resources, 2 needed at a time, like in our operation or something, you need multiple people together, resources are you being used in different locations, then you need to be precise with that information. Okay, all well, Anand? What about next thing? The same preparation is needed for entity B. Again, specialized location for entity B only, which is following triangular 3, 5, 10 minutes. You know what it means, right? Process, seize, delay, release, units. By the way, last time have you set the distribution? Have you entered the distribution with units set to minutes, not to hours? By default, I think it is set to hours in Arena. Yes, Kunal. See that again? Sorry. How do we add in? Oh, you connector. Can somebody figure that out? On the toolbar at the top, you'll see a symbol of connectors. You click on it, you click one point where you want to connect and the other point where you want to connect. So are you able to figure it out? Okay. Sorry? Oh, okay. What is that line above the process? She says that she's looking at a new line above the process. What is that line? It shows there that it is because it involves not just delay, like a room where there's no queue. So because there's a resource involved, it means that there is a queue. So that line shows like a queue. You can even drag that line and move it around, put it wherever you like. Okay. You can drag it before the process if you like, just for visual purposes. Or you can leave it at the top. At the top, I don't like at the top because it's like the queue is on top of the process. So I normally put it slightly behind so that you can visually see the queue behind. Okay. So have you done that for the second part? Okay, what's next? For entity, okay, I think we reached here. What? Here? We reached here. So both parts are then seeded one at a time on the same seeder machine. You understand this bit? Both parts. So there are 2 parts. They are preparing it and then they are sealing it. Some whatever mechanical parts are there. Okay. Now to seal, there is just one machine now, not 2 machines. 2 separate preparation machines, but now it says the sealing process for entity A and B are different. Both follow different distributions, but they are done on sealer. So just add a new process for sealer. But this is where it will get interesting. So even if you could identify the problem, I'll be really happy. Should be connected to. So this, is it coming when this process is coming? It is coming after the preparation, isn't it? So the entity is moving from the preparation to the sealer. You understand now? So the connection, the next connection would be between the two preparation processes both going into the sealer process, right? You understand what I'm saying? I'm still not showing you the solution. So it is like this. So you have you created like two processes, and now both are going into sealer. So this is prep A, this is prep B, this is create, and this is create, and now this is where it will get. I hope you're able to pick up the problem. So it says here, read this line here. I'll not be reading it. Just read from here again, a few times. Try to implement that line. Yes, on the same sealer machine. Same resource. Again, you're not paying attention to the details. Start implementing it. See where, don't take guesses. You have created one process, create another process, do the steps, follow the steps, see where you get stuck. So what do you do in a process first? Give it a name, right? Have you given the name? What next? You need a resource. Have you created a resource? Yeah, you can give it a name, whatever name you like. First, fill the box. Fill the box first. You're jumping here and there. So, have you filled the process box completely, like the last time? Done? So, there is a resource, right? So, what did you do last time? In action, what do you do? What did you do last time? Did you do delay, cease delay? Do cease delay release. Then what next? Yeah? Yes, a resource, not two resources. It never says two resources. It says just a sealer and both part. It's like a machine, you know, when this comes, you know, seal. When this comes, seals, right? Look, yeah, that's why you have to read it carefully. That's the example. That's why I brought this example. Two parts. See the example. Read from the beginning. That's why I read it first, maybe in one go. It says two parts in a manufacturing plant. You create things, right? There are different steps to create things. So the step is, first of all, the manufacturing plant is creating two different products. We call it entity A and entity B. So you take it to the first step where you prepare it, whatever way, not going into the technical details of it, maybe cutting it and whatever. And then it is bringing up, so they have their own processes for preparation. Okay. Then after that, they both come to a single process of, you know, single machine, single station for sealing. Like in foods, you pack, right? So you go to a farm, you go to, they can prepare cheese, they can prepare like meat, right? Do they do it in different places? They can do it in different places, right? Of course, they don't mix cheese and meat, right? But they bring it on a machine to seal, isn't it? But the sealing, this is how it's going. Two different products, prepared, brought, sealed. I think you're getting intimidated by me telling me that there's a problem. So by filling in the process, sealing process, have you given the name? Have you given it a name, the process? Sealer, whatever name, I don't care, I don't mind whatever name you give, okay? My question is, have you given it a name? Have you given it an action? What is the action? Cease delay only? Cease delay release, because there's still a resource. You're not saying it just waits and leaves, right? Or it carries the resource with it. Okay. Type, leave the type, it's standard. Okay. You're paying attention to everything except what I'm trying to bring. Not the priority. Now, let me just ask you a question. Let me take you there now. Okay. Have you defined the resource? Have you created a resource? Now start coming down. After defining the resource, what is there at the units is minutes. Okay, let's set units to minutes. The distribution, isn't it? You're not talking about distribution. What is the distribution you have to put in? You did that in the last one, triangular this and triangular that. So what is the distribution you have to give? Can you see the information here? Read again. However, the sealing process for entity A and entity B are different. Both follow. You're not reading. Not reading at all. So, how many distributions you can put there, and how would you identify which one is for whom? Oh, finally. You understand what the problem is? There's only one distribution you can define. And each one is following a different distribution, triangular and Weibull. We call it Weibull, whatever distribution. Do you understand the problem now? You know, when this one comes, it follows this distribution. So if I put this in the box, it's relevant for A, but when entity B comes, you know, this one will not work. You know, how would I change during the simulation? You understand the problem? Then I'll show you the solution now. But I was hoping that you catch this problem. So again, you are trying to overkill. I'm trying to create a trick or something. No, it's just about walking yourself through. You created a process. All you had to do was step one, can I fill the name? Yes, I can. Step two, can I pick the action? Yes, you can, right? Step three, can I set the units? Yes, I can. Step four, can I put the distribution in? Where is the distribution? Ah, there are two. That's all what was needed. You're looking for something, a tricky thing, right? For that process. Each process has, yeah? We will see how we can do that. That's the problem. I wanted you to see the problem here. That because on a single machine, there are two different sealing processes, both are following different distributions. So let me just, because you have collected the data, so let me first show you how they came into being, you know, those two distributions. So you have a paper where you say entity A, service time, entity A, you know, so there's a list for entity A, there's a separate list for entity B. So you're recording them separately because they are two different products. The sealing process is different, so they are taking different times, right? So you have one set service times for entity A, service time for, and then you fit them separately. In one sheet, you got this, and in the second, you got that. You understand how we achieve that? So there are two different things. So they are getting different service. So we are able to find different distributions. So how are we able to do it? I'm going to show you a small trick here, which will be helpful to you. There is something called an attribute we talked about when we were talking about the introduction to simulation. Do you remember that? Attributes and variables and entities and resources. So what was attribute? I'm not going to tell you. You have to open and find it out. Yeah, sorry. Okay, fine. So it has to do with, and variable has to do with the whole system. Excellent. Now, can I put like a name on my, when I like a card? You know, we go to a university, we have like a card holder. So I can, what the trick I'm going to be using is I'm going to be carrying my own distribution with me. You know, like written that this is the distribution. So when it comes to a sealer, what Arena will do is look at that attribute value and see that, okay, this is the distribution for this one and this is the distribution for this one, and use whatever is there. Okay, conceptually you understand what I'm saying. So there's a trick we are playing. It's not really physically that's happening, but this is how we are going to play with the system. So there's something called an assign. You know, you may have seen in the basic processes. I don't know. I've seen that in the newer version, they are setting it up in a slightly different way. But do you see anywhere assigned? Yeah, here is an assign for me. You have to find it out for yourself in which toolbar you have assigned. Assign and let's just keep assign. You can give it a name, or you can leave the name as it is. It's okay, just call it. But the point is, where am I putting this assign? After creation. So delete this connection. Okay, delete this connection between create and the first process. I'm putting it here for a purpose. I can put it even just before senior as well. But there's a purpose. I'm doing that for a reason. Okay, so I'll let you know about that later. But make sure you first delete this connection. Mana, first delete the connection, drop it, and then create new connections. Okay. You understand what I'm saying? Yeah, you have to drop the old ones, and then drop it, and then create connections like this. Now you'll see nothing in there, right? Just click on add. No, variable, but can you drop this down? Do you see something called an attribute? Because I want each entity to carry its own distribution. So if I say variable, it belongs to the system, not the entity that passes through it. Sorry, attribute, you pick attribute. So I'm going to click on attribute, and I'm going to give it a name. I'm going to give it a name, any name you like. I'm calling it sealer time. I'm calling it sealer time. So the name of the attribute is sealer time. But make sure whatever you type here, just copy it. Let me use the magnifier so that you can see it better. Oh, can you see it now? Now, when you type this name, copy it, please. Control C. Why am I saying this? In the process. Oh, that's great. You're able to pick that up. Now, because both types of entities have the same attribute, so you just put the attribute name in the distribution. I'll show it to you, it will become clear in a second. Don't worry. But the attribute value is what? What attribute value do you see here for entity A? It's the distribution that you wanted it for entity A, right? Can you see that? So type that try A134. Now I'm going to do the same for the other entity. I'm going to add and assign, okay? And I'm going to add an attribute called what? I'm going to create an attribute called exactly the same name. Small difference, it will not work. You'll see why same name must be there logically when you see the next step. I'll show you the next step and everything will become clear. But this is the second one. WEIB 2.5, 5.3. Yes. Yeah, these are the distribution. You can see TRIA 134, sorry. 134, and this one WEIB 2.5, 3.5. Okay, done, Manat? Are you okay now? You give, the point is, whatever attribute you need, you give to the first one, give the same to the second one. That's why I say copy it, because even a space or capital or small, just whatever you type here, copy it for the first one. Just make sure that this is same for both, and still keep it copied. Still keep it copied, okay? Let me know when you are done with this step. This should look like this, okay? Yeah, sure. (2.5, 5.3). WEIB. Make sure WEIB is for viable distribution. Not two attributes. An attribute, same attribute, just like name is an attribute. You understand that? Even if there are two different entities, name is an attribute, right? So it's like one attribute for two different kinds of items, right? Now, can I move to the next step? Now in the sealer, do you want me to wait? So now there's an option called in defining the distribution. There's an option other than triangular. We call it expression. What do you see in expression? Okay, let me just go back here. I'm now coming back to sealer process. Going in there, I've already defined the name. Okay, CCLA release resource. Now I have minutes. Now I have to kind of define the expression. Okay. No, not 2.5. We have done something. Now imagine entity A arriving. What's the value of sealer time? What's the value of when entity A? What's the value you have given? Triangular. So when entity A reaches, what's the value of sealer time? Triangular 134. When entity B reaches, what is the value of sealer? You see how we are handling it? It's a trick you needed to know. Now you understand how we are handling it? It's a trick used by making use of attribute values. Okay? No, it will be one at a time. It clearly says one at a time. There are, if you want two to be coming together, this is a more advanced topic. There is something called join. We are not doing that right now. So first you ask them to join. I'm going to show it to you here, but just for your knowledge, okay? Advanced process, you'll see something called remove, join, somewhere, I have to like zoom out or something, right? So, but there are some advanced places where you're able to, separate, clone, batch. I think batch is like one way of joining them. So that's an advanced version. We need to figure out how this is done. Batch and separate. I think it's not join, it's batch and separate. Batch puts them together and separate, separates them. Okay, so do you understand the trick? The whole purpose of this exercise was to make you know this trick. Okay, so if big trolleys, small trolleys, following different service times, coming to a single cashier, you know how to handle it now. So you find their distributions, service time distributions, right? You use the assigned attribute and you put respective distributions, and then in the process, you use expression and use that attribute. So this is a solution in case you're facing that problem. So the whole purpose of this exercise was, if you're facing this problem in your project, then this is the way to deal with it. All clear, Manat? Now let's see one more issue that you might face. And let's just go and read again. So this is nothing but preparing you to deal with different situations. I'm going to, where is my Zoom? Okay, I'm going to keep it here. So we have read up to what point? Yeah, we'll have to read from here, okay? Okay, the sealed parts are then checked for quality. Where are we? One at a time at a single quality desk. So what are we looking at? A new process where both parts will stand in a queue one by one. They are checked for quality, whichever comes first. Okay. Where historical records suggest a 9% failure rates across both entities. So they are doing quality check at the station, okay? And out of 100, 9 parts are rejected and 91 parts are accepted. Random. Right now we are dealing with it randomly because we don't know which one is there and which one not. We just have to think, oh God, it happens every time. Okay. Oops, not again. Okay. So you understand what's happening. So because there is a rejection, it says what? Let's move on. So the accepted parts are shipped. So after quality, the 91% parts are shipped, or as we say in Arena's language, they are directly disposed. Disposed don't mean throw them out, it means they're out of our system. The failed parts are sent to rework shop. So you're now looking at one more process that is following exponential 45. Okay. After the rework, the parts are checked again for quality. So the 9% part that failed, they went into a rework shop and then checked for quality again. So either you can push them back, but we are making life simple. We're saying that there's a separate quality check for them. Okay. So after that, and then it says the historical records tell us that the failure rate is still 20%. So for the ones that you rework, 20% still failed. They're too bad to be fixed. The failed parts are scrapped or disposed, and rework accepted parts are what you call salvaged. Sent to a lower grade market. So let me show you the screen so that you are able to visualize it. I know it's a little bit challenging process, but you understand this part. You created entities. You know why we are putting in a sign. We didn't do that in the beginning. We prepare them, and then we seal them, and we decide that we never mentioned that there's any process here. We just say that although there can be a delay here, but we simply say that out of these 91% goes here and 9% goes there. So there's a decide. We use what we call. Let's try to implement this first, but after that, the rejected ones, they, the 91%, they go outside. Forget about, there's something you haven't read, but there's something like assign something extra, okay? So they go and they get disposed. And then reworked, and then out of reworked, 91% are 20% are scrapped, the remaining are salvaged. Okay, at least you understand the whole thing. Now let's see how we can deal with that. So after sealer process, just add an inspection center. Imagine it's like an automated inspection, so it doesn't take time. So once you add that, you'll see that this side is like an input. This is where the things are coming in. Okay, Panat? Okay, what do you see here? I don't think you can see here. Let me zoom that in. What do you see written here and what do you see written here? Okay, so when a condition is true, yeah, so % true. I say it's up to you, entirely up to you, which one you're considering true and which one you're considering false. I say 9% is true, which means the failed parts. So the true side will be taking care of the 9%, the failed items, right? So there's no true and false. Is you define your own true and false in this case, okay? Everybody understand that? Now there's something else I'll show you because for your projects at the end. But let's just finish this, okay? So where's false? It's obvious. So you don't have to write for the false, right? It's a binary thing. What is left is false. So, and you forgot to see something here very nice. Drop it and see what do we have here. So it could be by condition. Condition like I have two checkout counters. If the queue for this one is longer than the queue for the other. I'm just giving you an example for two-way by condition. I'm just giving you that where you make use of all these things, okay? So the example for two-way by condition is there are only two checkout counters. I come to the counter, I see which queue is longer. I say if this queue is shorter than the other one, I join there. That's called two-way by condition. So what is n-way by chance and n-way by condition? More than two, right? So if we have not just 5% here and the rest there, I say 5% here, 10% here, 20% there, the rest there. Okay? Or n-way by condition is I'll see if this one is shorter than the rest, I join this one, and so on. Right? You understand that? We'll look at that later. But this is a crucial thing for all of you to know. Okay? So we are using two-way by chance for now. And you have to write like 9%. So the whole example is available to you. I want you to look at it later because the whole example is available, right? So you can keep on building it up. You can try it out yourself, and
you can see that after rework, we have 20% failed and 20% true goes to scrap and the rest goes to salvage. Okay. Now there is just one more thing. It's asking at the end, you also need to record average times spent by scrapped, salvaged, and shipped parts in the system. Okay. So how can I record that time? Not in the reports. No, there's no explicit way of doing that for the C part separately. I'm going to put another new attribute. When an entity enters the system, I want to record the time. And when it leaves, I again want to record that time. And then I want it to take average. Yeah, it is a complex problem. But you in exam I don't know. I want you to be scared at this moment. But inshallah it will be fine. You need to go up a little, right? You need to know. Yeah? In exam? Let's pray to you have to work hard and then pray to God that the question remains easy. That's called EBM. You know what does that mean? It's called emotional blackmailing. When you say, I will trust you, then okay, I have to be very nice. But I think I fell victim for that, so it's okay. Inshallah, it will not be this complicated. It will be reasonably easy. Don't worry, it will be not like this is the hardest one we are solving for you to know all the at least tricks. If you face with simulation real world problem, you need at least these things. You need to know create, you need to know process, you need to know assign, you need to know record. If at least you say I don't know any of these, advanced ones are fine. But if you say I don't know these, your boss will say, you're telling me that you knew simulation. So this is like the baseline, for simulation, to claim that I know simulation. Okay. So that's why we are solving this quite hard problem. Not hard problem, at least at your stage, it is a bit hard problem. Okay. Because we are doing too many things. So one of the things I'm going to just show you is T now as an attribute. So arrival time or arrive time, and I'm going to click it now. So just this value T now is actually we just need you to know. In fact, I can show you how it came. Build expression. And then there are so many things that are available. Current time, maximum time, this time, that time. Many pre-made functions are there, but we are not using it for now. I know you're getting overwhelmed, so I'll just say you record that time, and then we make use of that T now here to record time. It's okay. I'm not going to go any further. It seems like it's getting too much in a single class. So that's how it is done. Now, just one small step that you must know. I cannot skip that. That part is now shown here. So at least you need to tell me where is that thing happening. No, this one. The process runs for a day, 5 days, and for 50 days. Okay. So where do I need to go? Setup. 16 hours a day. Okay. And it says how much? Maybe I did not fill in. Well, yeah, 50 days. 50 days. Okay. And that's it. You run and you record and then you're done. Now there's just one small thing left for you to learn. N-way by condition. Okay. Two-way by condition and then N-way by condition. And then
you are done with simulation and you are equipped to solve, the simulation, uh, your projects. So let me just go open this one. I'm going to show you something which will be helpful. Okay, we still need one more class for your projects. What do you see here? Oh, let me just zoom that in. So what do you see here? Two-way by condition, I'm going to delete it. Okay, and I'm going to say okay. So what is happening here? It's like hyperpanda. You enter, you see whichever queue is shorter, and then you go to that counter and then you leave. Okay, so see how am I handling that? That's because you need that in your projects. So first I need to go to expression. Okay, and that expression, I have to build that expression, and I'm saying that in the queue, if current number in the first queue, process one, do you see it's process one here? If it is less than the NQ, the current number in, so if this condition is true, go that way. That's it. If false, the other way, right? You understand how it is handled? Now, if in exam, if you see a condition like this, that condition expression will be, that NQ and the whole thing will be given. Okay. But the size of the model will be very small. You'll have something very small to deal. But we needed to know whether you can use, how to use create, how to use process and decide. The rest are additional information, the assign and the record. Oh, you are, I think I was getting affected by the EPM. I'm telling you more. Okay. So, yeah. Yeah, so inshallah, you'll be able to develop that model in maybe like 5-7 minutes. Don't worry about that. Okay, we have to push you hard for this. If you can do this, then that is like you can do it. If you're right-hander, do it with left hand, and if you're left-hander, do it with the right hand. Okay, now we can stop now. Now what's next? You are now equipped with everything you need. Create, process, decide, assign. There's no record we are using, right? Try it out yourself, but I need even half-running, half-code problematic models here in the class. I need to see all your models on Monday. We'll debug the models and we'll inshallah fix it. I'm going to tell you where I'm sure there will be a problem. The problem will happen when you have not two-way by condition, but when you have n-way by condition, which is fine. We are going to solve it inshallah in the next class. Okay, but this is where I feel that you may struggle. If you are able to do it, I'll be really, really happy if you can figure that out. But you have to think of logic the way I used here. If the queue size is greater than this or greater than the same queue is greater than this or and, so you have to use or and ands. You understand what I'm saying? So if this queue is greater than this and the other one and the other one and the other one, you go this way. Are you able to follow me? If you can't do that, we'll sit together and we'll implement it here in the class for each one of you separately. Okay? Because this is the only thing I left for you to first try it out yourself. Okay? Now we can stop here unless you have a question. All clear? No. What I'm saying is you need to develop something, ideally a working model before the class. If there's a problem, it's absolutely fine. Like we do in Python, we'll fix it here. I want you to first give it a try all by yourself. I've tried to prepare you with all the tools you need. Still, you need synthesis. You need to put them together, which is still a challenge. But you need to be creatively thinking, this, I need create here, I need process here, I need like decide here and so on, right? Try your best, okay? And then if inshallah, if there are some parts not working, we'll fix it out inshallah on Monday. We'll try our best to finish it on Monday, not take it to Wednesday. Okay. Anything else? Yes. You tell me where you're getting those numbers. And so these distributions, somebody collected the data for arrival, for the processes, in the sealer as well, in different creates and all the processes, even separately for each entities, and then they took it to Arena Input Analyzer. Like I showed you last time, right? The Excel file, you put it in a notepad file, you save it as a DST file, and then you fit it in Arena, you copy that line and save it somewhere. You got that? So you already have done that part for yourselves, right? Even we did it without input analyzer, right? We directly, because we knew it was exponential, so we just found the average and lambdas, and we are able to find the value. Okay. Okay. So anything else? Let me just talk a little bit about it. Oh, sorry. Okay.